Today we are going to discuss about ionic radius. There are two types of ions as cations and anions. Ion is a charged molecule and there are two types of such charged molecules. Some bears a positive charge, some bears a negative charge. Ions with a negative charge are known as anions and ions with a positive charge are known as cations. Cations are formed by removing electrons from a neutral atom. So, number of protons are higher than the number of electrons so that the atom gets a positive charge forming a cation. For example, we will take sodium like this. Here 2 electrons, 8 electrons and 1 electron. When this particular electron is removed, it becomes Na plus, right? Then anions. Anions are formed by accepting electrons to a neutral atom. Because of that, the number of protons become less than the number of electrons. As electrons bear a negative charge, the atoms get a extra negative charge. So, atoms with a negative charge are known as anions. We can take hydrogen for an example. Here one electron is already there and when it accepts an electron, it becomes hydride ion and anion. We are going to compare the radius of cation and neutral atom. We have taken sodium and sodium plus to be the examples. Sodium is the neutral atom and sodium plus is the cation. So I am going to first of all draw these two. There are 3 energy levels in sodium and in sodium plus there are only 2 energy levels like this. 11 electrons in sodium, 10 electrons in sodium plus. Like this. So if we compare these two on the basis of number of energy levels, you can see that here number of energy levels in sodium is higher than the sodium plus ion. So here is sodium and here is sodium plus. We know that when the number of energy levels increases, atomic radius increases. Here we compare ionic radius and atomic radius. So same factors come to ionic radius as well as atomic radius. Now we know that in the base of number of energy levels, cation radius is less than neutral atom radius. What is the reason behind that? Number of energy levels in the cation is less than the number of energy levels in the neutral atom. You should remember something. It is not always true. I mean, number of energy levels is less. Likewise, that factors are not always true. We have taken here sodium and sodium plus ions. If you took another two, it may be different. The factors may different, but the theory is same. You should remember this point. Always compulsorily cation radius is less than neutral atom radius. According to the cation and the neutral atom, you should compare the factors, right? It is based on the situation. There are 3 factors that the radius depends: number of energy levels, effective nuclear charge and the screening effect. You should decide it that suits for the point. In this situation, number of energy levels in the cation is less than the number of energy levels in the neutral atom, so that cation radius is less than neutral atom radius. Then if we compare these cation and neutral atom radius on the base of effective nuclear charge, there are 10 co-electrons in sodium and only 2 co-electrons in sodium plus ions. Atomic number minus number of co-electrons gives us the ZeEF value. So here sodium has 1 as the effective nuclear charge value and sodium plus ion has the 9 as effective nuclear charge value. So cation has more nuclear charge than the neutral atom. We know that when the effective nuclear charge increases, nuclear attractions become higher. When the nuclear attractions become higher, radius becomes lower. By considering this point, we can say that cation radius is less than neutral atom radius. Right? So I have compared the sodium and sodium plus on 3 factors. Each and every factor is considered here. But you should not go like this. If it asks about the cation and atomic radius in somewhere, you can choose a suitable factor and compare these on that factor and gives your conclusion. But the conclusion is always the same. Cation radius is less than the atomic radius. Then we will consider the screening effect. So in sodium, the inner electron number was 10. But in sodium plus ions, the number of inner electrons was 2. When the number of co-electrons increases, or when the number of electrons in a particular atom increases, electron-electron repulsion increases. When electron-electron repulsion increases, screening effect increases. When the screening effect increases, nuclear attractions become low. Because of that, radius becomes higher. So in sodium, number of electrons or the inner electrons is higher. Screening effect is higher there than the sodium plus ion. So we can say that the atomic radius is higher than the cation radius on the basis of screening effect also. Now we will discuss about the anion and neutral atom radius. I have taken chlorine and chloride to be the examples. So first of all, I will draw these two atom and the ion. You can see here, number of energy levels of these both is the same. Because of that, we cannot compare the radius of these two on the base of number of energy levels. We should neglect that factor because they both have the same number of energy levels. Chlorine have 17 electrons, chloride have 18 electrons. So I have drawn it like this. We will take the effective nuclear charge of these two. You can see the effective nuclear charge of these two is also the same. 17 minus 10 is the effective nuclear charge, and effective nuclear charge is the force given by the nucleus to the outermost electrons. So in chlorine there are 7 outermost electrons, and in chloride there are 8 outermost electrons. Nucleus gives 7 charge to both chlorine and chloride. So if we divide this by 7, it is 1, and if we divide this by 7, it is less than 1. It is less than 1. So more attraction is given on the outermost electrons of chlorine than chloride. Because of that, when the number of nuclear attractions increases, atomic radius decrease. So we can say that the anion radius is greater than the atomic radius. If we go on a flow, effective nuclear charge of these two is the same, but the number of outermost electrons in chlorine is lesser than chloride because of that nuclear attractions on the outermost electrons of chloride is lesser than chlorine. Therefore, radius of chloride is higher than chlorine. Then we will move on to the next factor. Number of electrons in chlorine is less than the number of electrons in chloride. We know that there is a factor called screening effect or the shielding effect. Co-electrons in both chlorine and chloride is same, but we should think about this. When we consider chlorine and chloride, number of electrons in chlorine is less than number of electrons in chloride. When the number of electrons increases, electron repulsion increase. Electron repulsion means screening effect. When the screening effect increases, nuclear attractions become decreased. When the nuclear attractions become decreased, radius increases. So at the end we can say that atomic radius is less than anion radius. So each and every factor concludes that ionic radius, that means anion radius, is higher than the atomic radius. So as a previous one, you should be wise enough to select the factor that suits to compare the given anions, atoms and cations. Each and every factor doesn't suit for every situation, right? But the final conclusion of all the radiuses is this way. Anion radius is the highest, atomic radius comes the next, and the cation radius is the least radius, right? So that is a conclusion. We should know what an isoelectronic series is. Series of ions or elements with same number of electrons is known as isoelectronic series. If you consider oxygen 2 minus, fluorine minus, neon, sodium plus, magnesium 2 plus, you can see that there are 10 electrons in each. So if such isoelectronic series is given to you with the same number of electrons, here is a tip for you to find the radius. When the negative charge becomes higher, the radius becomes higher. Negative charge එක increase වෙද්දී radius එකත් වැඩි වෙනවා. You can compare it by own studies. So when the negative charge increases, it says us that the number of electrons increases, right? When the number of electrons increases, electron repulsion increases, screening effect increases, nuclear attractions decrease, therefore atomic radius or the ionic radius increases. But when the positive charge becomes higher, the radius becomes low. When the positive charge increases, effective nuclear charge increases, nuclear attractions increases, that decrease the atomic or the ionic radius. So, if you are given an isoelectronic series, you can keep this in your mind. නෙගටිව් චාර්ජ් එක වැඩිම කෙනාට තමයි වැඩිම රේඩියස් එකක් තියෙන්නේ. පොසිටිව් චාර්ජ් එක වැඩිම කෙනාට තමයි අඩුම රේඩියස් එකක් තියෙන්නේ. So if we took these things in the increasing order of atomic radius, we can say that magnesium 2 plus, sodium plus, neon, fluorine minus, and then oxygen 2 minus. So that is the end of the. Thank you for being with me till the end.